Okay, this video is for questions 11 through 15. 11 is from section 5.1, so this is recent. Determine whether the function is one-to-one, and if so, then find a formula for its inverse. The fastest way to check if it's one-to-one is to graph it in your calculator and confirm if it passes I'm just going to call it H line test, the horizontal line test. Because if it passes the horizontal line test, then yes, it is one-to-one, and that means you can find the inverse equation. So this is just a linear function. So yeah, it's going to pass the horizontal line test. Now you have to actually, so you know C is not the answer. Now you have to find the inverse. You're going to switch X and Y, and you're going to solve for Y. Okay, so this is f of x. That's a fancy y. I'm up here, Reese. So I'm going to switch, and I end up with this. Now I'm going to solve for y. I would add 5 over. Oh, watch out. Okay. You don't have to, okay. Yeah, you don't have to shut that, Reese. Okay. Solve for y by moving these terms. Sorry, y'all. Reese is playing. Um, and then now we're going to divide by 3. And now we're not graphing this, so where I usually say, don't write the whole thing over 3, you can do that here because we're not graphing it. We're not trying to read the slope. So if you look at your answer choices, you can see that the correct answer here is B. Number 12, solving a radical. This is from section 3.4. Just like when you're solving absolute value, you have to isolate the radical. So in this case, I'm going to subtract 7 to the other side, which is what gives me x plus 49 under the radical, and then I have x minus 7. Now the opposite of square rooting is squaring. When I go to square this side and then square this side, on the left it cleans up nice and I just have x plus 49 because those were inverse operations. On the right though, please remember that x minus 7 squared is not just x squared plus 49. Please don't write that. A lot of people jump the gun on that and they forget there's an entire middle term in there. So you have to multiply this out. If you look at my answer key, let's see, I went straight because I did the shortcut. Okay, so I'll just come over here and write it. So you have to multiply this out in expanded form. And now you can do the whole first, outer, inner, last, which is what gives you this polynomial here. And now you can see why that was not the correct answer because there's a minus 14x in here. Now it's quadratic, which means let's get everything to one side and let's solve the quadratic. So we end up with minus 15x. When I subtract 49, they disappear. So I have this nice just two-term quadratic. If you recall from the very first video I posted, when you have two terms for a quadratic, look and see if there's a GCF, and there is. And then you can set each factor equal to 0 and solve. Now you do, because it's a radical, just like with fractions, you have to check yourself before you just run with these answers. So go back over to the original. Let me rewrite the original. The original was the square root of some number plus 49 outside of that plus 7 equals some number. So I'm going to check 0. Okay, so square root of 49 is 7. 7 plus 7 is not 0. And you might think, well, the square root of 49 could also be negative 7, and negative 7 plus 7 is 0. The problem with that is the only time you take the square root and account for both positive or negative is when you're solving. We've already solved. We're now checking our answer. And so the square root of 49 is 7, and then plus 7 is not 0, which means 0 is what's called extraneous, which means algebraically it was an answer, but when I go to plug it in, it doesn't make a true statement. Now I'm going to check 15. 15 plus 49, 64? Square root of 64 is 8, plus 7 is definitely 15. And so you would mark that A is your answer, and you would list 15 right here. Okay, number 13 is from section 5.5. This is one of the last sections we covered. If you notice, you have an exponential on both sides. So there's two ways to approach log and exponential and ln and e equations. If it is a single log, or I'm going to write all these words, log or exponential or e, and then equals some number, then you want to convert, because then you'll see how to finish solving it. But if it's multiple, then you can't convert. You can either rewrite it with the same base, or you can solve it by applying log or ln to both sides. So if you look at this, I have an exponential equals an exponential. My bases do not match, and there's no way to manipulate them to match. So the way to approach this is I'm going to apply log to both sides. And the reason I'm doing log is because log is the inverse of exponential. So here's how it would look. It would look like log 8 of x plus 6, or to the x plus 6, equals log 6 to the x power. Now we're going to use our rules with logs. We've got stuff up in the exponents. This is multiple things, so it would help to put this in parentheses. I need to pull this to the front. I need to pull this to the front. So that gives me the quantity x plus 6 times log 8 minus x, or equals x log 6. This is multiple things times log 8, so you're going to distribute it. You have x log 8 plus 6 log 8. Bring down the right. And now you should notice that you've got 3 logs here, and 2 of them have an x term. 2 of them have an x term. Let me change that because that was too much. We have this log expression with an x and this one with an x. It's going to be really hard to solve for x if I have them on opposite sides of the equation. So we need to shift. We're going to play the cup game. This is going to subtract to the left, and this one has no x, and it's going to subtract to the right. So when I write x log 8, which just came down, this subtracts over, equals, and then that subtracts over, so it becomes negative. And now we've got our x's on the same side. And notice they're both in the front. So let's factor an x out. Now we've got x times this log expression. It's attached by multiplication, so we're going to divide it. So we would have that negative 6 log 8 on top, all over log 8 minus log 6. And this is what you would go to your calculator and type. You would, let me pull my calculator up. You're going to enter I would enter the fraction format to make it easier to be able to see that you're entering it correctly. Oh my, slide that over. Okay. So alpha y equals, and then I have negative 6. I can push the log button here because it's a natural understood base 10. Then on the bottom, I've got log 8. You do need to put the close parentheses minus log 6 and then hit enter. Oh, I may not be in real mode. Oh, well, that's a teaching moment. I accidentally hit the subtraction sign instead of the negative there, so it does matter since that was in the very front. And so now you can see what answer. They do say to round to the nearest, round to 3 decimal places. That means you're checking the fourth. So the fourth is higher, high enough to bump it. So the 9 becomes a 10, which means 69 would read 70. And that's why the answer is B. Number 14, solve the inequality. Remember, you're going to treat it like it's an equation. When it's a simple inequality like this, treat it like it's an equation, solve it, and then just test some points. This will factors of negative 35 that add up to negative 2. So we come to critical point 7 and negative 5. You would draw a number line, plot 7 and negative 5 on there in the correct order. Pay attention to your sign. This means open. So we have some points to check. I always test 0 because it's easier. You are testing it back in the original. So if I plug 0 in, I get negative 35 is less than 0, and that is true. Then I would go to my calculator and I would also test negative 6 and 8. You will find that they are false. You shade where it's true, and then you write it as an interval notation underneath, and then you can see that your answer is B. Remember, whatever answer you come to, your interval notation, you should be able to pick a number in that interval, plug it in, and it be true. So that's a way to check yourself. Number 15 comes from section 1.2. It says find the domain. Well, it's a fraction, so you got to remember the rule in math is that the denominator of fractions cannot be 0. So you look at it and you say, well, what would make it 0? Well, 9 would make it 0. That means 9 is off limits, which means imagine an entire number line being shaded, but you're hopping over 9. They have given you 2 options here. They're giving you the set and then the interval way of writing the answers. So if you look at it, you can narrow it down to C or D. Hopefully you just remembered that if the factor is x minus 9, then the value that's off limits in this case would be positive 9, which lets you determine that D is the answer.